Daniel is the owner of a family-run fruit store in Singapore. The store specializes in seasonal, premium products. During the months of June to September, the main seasonal product that can be found in the shop is the durian, which is known to be the king of fruits in Singapore. Given the popularity of the durian, it is one of Daniel's most revenue-creating businesses throughout the whole year. However, he realized that at the end of each season there is quite a lot of inventory left over. The old durians lose their flavor and sweetness, so he needs to sell them to bakeries for only 35% of their initial cost. At the same time, he is scared that, if he reduces the quantity he usually orders, then he will run out of durians and have unsatisfied customers. Return customers are very important for this family-run business. Therefore he currently prefers to have durian leftovers than run short on them. Currently Daniel does not have a forecasting method in place. Before each durian season, during the past 6 years, he has been ordering 10 tons of fruits every year. These orders are placed ahead of time and they are delivered periodically, all throughout the durian season. The cost per kilo of durians is $8.50, and he is able to sell them at a price of $17 per kilogram. Daniel realized that each season he has around 1 ton of fruit left over, which he can only sell to the bakeries at a price of $2.90 per kilogram. The contract that he has with the supplier does not allow him to change the quantity ordered each season. However, soon this contract will renew, and Daniel is now looking for a better, more reliable ordering strategy. He wants to find an order quantity that will maximize his profit, but at the same time not take a lot of risk in terms of customer satisfaction. We suggest that the news vendor model for continuous demand is an appropriate approach for Daniel's issue. This will help him make a better single-shot commitment, in anticipation of an uncertain demand for durians. This model applies in our case because the durian is perishable. A seasonal product, ordered once per period, follows a normally distributed demand and confronts with uncertainty. We will solve Daniel's problem in a two-step procedure. First, we are going to calculate the parameters of the demand distribution, assuming that it is normally distributed due to the central limit theorem. Secondly, we solve the profit optimization problem.
We aim to maximize the profit through finding the optimal order quantity, the quantity that Daniel should order at the beginning of each durian season. Here in the table we can see demand data from the past 6 durian seasons. The total inventory available at the beginning of the period is the total quantity that Daniel orders for the next 3 months. The excess inventory is the difference between the total inventory available and the demand. The total inventory available is the excess inventory from the last period. From data gathered from Daniel, we know that the selling price is $17 per kilo, the cost per kilo is $8.50 and the salvage value is $2.90. Therefore we can calculate the revenue for each day of the durian season, which is price multiplied by demand. The excess inventory at the end of a period becomes the leftover product, which cannot be sold anymore under normal conditions. This leftover will be sold at a lower rate, its salvage value. As we can see in the table, the shop has had quite large amounts of leftovers in the past 6 periods, totaling 8,232 kilos. We can calculate the total revenue by adding up all individual daily revenues. The total costs are the cost per kilo multiplied by the quantity of durian ordered during the last 6 periods, which is 60,000 tons. In order to find the useful distribution parameters, we perform data analysis. This is done through the add-on package that can be found in the Data tab. Here we select descriptive statistics and we obtain the table that describes our demand distribution. For our calculations we will need the mean value of 70.72 and the standard deviation of 6.91. With these values we can now calculate the optimal order quantity. Durian season is known to last for 4 months, or 121 days. With the price and cost values we can calculate the overage and underage costs. The overage cost is the difference between cost and salvage value, which takes place if Daniel orders too much. The underage cost is the difference between price and cost, and it takes place if he orders too little. Now we can calculate the critical ratio, or the relative importance of stockout cost versus markdown cost. The critical ratio affects the direction and the magnitude of the order quantity. If the critical ratio increases, then the overstock cost is less significant, which means that Daniel could order more. If critical ratio decreases, then it is the reverse case. To maximize profit, we choose the quantity such that the probability we satisfy all demand equals the critical ratio. The expected profit maximizing order quantity balances the too much too little costs. A wrongful interpretation of the costs and the critical ratio could lead to the failure of a company. The Z parameter, which is the inverse normal cumulative distribution for the probability value critical ratio. We convert the Z static value into the optimal order quantity by summing the mean and the product of Z and standard deviation. We find that the optimal order quantity for durians is 8,577. In order to make a comparison between the news vendor model and Daniel's current ordering strategy, we have to determine the new cost. This cost uses AFZ value as parameter, which is calculated with the formula norm.s.dist. With this value we calculate the new cost, taking into consideration overage and underage costs. Then we can calculate the profit during one durian period, which is the margin multiplied by the expected demand, minus costs. As a last step, we compare the profits using the two methods. We see that by using the optimal order quantity, Daniel would have had a profit increase of $40,005, which is 10% increase.
We previously saw that using the news vendor model would have given Daniel an extra $40,000 in profit during the past 6 periods. Therefore, our recommendation is that he should set the new contract with his supplier for an order quantity close to 8,577 tons of durian per season. In addition, there are several other managerial actions that Daniel could take in order to increase his profits, such as, try to increase the salvage value of each unit. Take actions to reduce lead time, which leads to lower and more often ordered quantities, less inventory, but same product availability. Tailored sourcing. Tailored sourcing implies using a combination of 2 supply sources, and the 2 sources must focus on different capabilities. One focusing on cost but unable to handle uncertainty well. The other focusing on flexibility to handle uncertainty, but at a higher cost. Tailored sourcing contributes to increasing profits and better matching supply and demand.